Hello, my name is Bulim Choi, manager at the Logistics Research Department of Busan Port Authority. It is an honor to have the opportunity to introduce Busan Port like this today. In this session, I will explain our ongoing budget, the Intelligent Automation Smart Logistics System construction project. With the arrival of the Fourth Industrial Revolution, a new paradigm is expanding in the logistics sector. Major trends include smart logistics centers, automated ports, development of autonomous driving, and smart safety management. In line with these paradigms and trends, we conceived a project to build an unmanned automated smart logistics system suitable for the Port of Busan, and the project consists of three main areas. First, we aim to localize smart sensors and apply them to the port through sensor fusion. Second, we aim to develop IoT-based logistics center facility equipment automation technology. Third, we aim to develop an integrated control platform for cargo to develop technology that collects and analyzes cargo location and status in real time. Next, let's take a look at the market status of R&D targets. Looking at the logistics market, South Korea has shown a stable growth rate of about 2.8% over the past 10 years. On the other hand, the global logistics market is growing at an average annual growth rate of 7.3% and is expected to double by 2026. Smart sensors are expected to maintain steady growth at an estimated $30 billion, logistics robots at $6.43 billion, and cargo management and control at $11 billion. We will now look at the technical status of the three research areas. We will first start with a discussion on the technology related to port logistics smart sensors. In the case of LiDAR sensors, the U.S. company, Velodyne LiDAR, is leading the industry while continuous R&D is performed. In the case of sensor fusion, the South Korean company, Hyundai Motors, is steadily promoting sensor fusion for autonomous driving. And in the case of automated terminals, highly productive automated terminals are currently operating in China and the Netherlands. Furthermore, the U.S. company, Xvila, is continuously expanding and applying improved quality of service in terminal operating systems. We will continue to cover the IoT technology logistics sensors. In the logistics technology level survey conducted in South Korea, the U.S. is leading in all fields, and South Korea has reached about 80% of the technology level in comparison with the U.S., with a technology gap of 2.8 years. In the case of high-tech logistics centers, LG CNS is continuously striving to improve the technology level by providing solutions through monitoring IoT-based facilities. In addition, logistics robots and automation are emerging technologies for the logistics centers. Lastly, let's look at the current status of the Smart Cargo Integrated Control Platform technology. The device for cargo control is a technology led by Orbicom in the U.S. and has already been commercialized, with many shipping companies using the technology. The world's largest shipping company, Maersk, is using more than 300,000 container monitoring systems for refurbished containers. As for the control platform, various domestic and international associated companies are actively promoting the development of this technology. The subjects that the Port of Busan intends to develop through this project are displayed in the image here. By applying smart technology in the spatial range of ports, from ports to logistics centers, and configuring terminals and platforms that can control various information on cargo that may be generated here, we plan to ultimately transform the Port of Busan into a small port. Now, I will introduce the detailed research content. To begin with, we will discuss the localization of LiDAR sensors and sensor fusion. The fusion sensors will be applied in the three following fields. First, it is a foundational technology for autonomous driving of transport equipment, container cargo safety, and coastal monitoring. We are also developing fusion sensors, including LiDAR and autonomous transport equipment, and constructing a 3D map of the port for simultaneous mapping, as well as developing technologies to control it in the terminal operating system. Then, next part is about container cargo safety, with a second area of application of LiDAR sensor localization and sensor fusion. The developed fusion sensors promote continuous development to recognize moving objects, such as workers and transport equipment, as well as check the alignments of loaded containers. Furthermore, we have developed a technology that can link with the terminal operating system in order to monitor and control. The final field of application for sensor fusion is coastal monitoring. We aim to develop sensors that can be easily applied to various environmental changes that may occur in the coast to perform vessel identification, tracking, and abnormal behavior identification. The developed sensor will be linked so that the terminal operating system can control it. Following the sensor fusion, I will introduce the IoT-based logistics center automation technology once more. First, among logistics center automation technologies is the development of the IoT sensor module technology. We are developing technologies that can monitor and control real-time status information of logistics equipment through IoT sensors. In addition, we plan to continuously monitor the loading status of logistics center through cargo identification and implement it in 3D. On top of this, it is made possible to check the internal environment through a computer or mobile device without having to go to the distribution center. I will now discuss the development of remote control technology for equipment in logistics centers. 5G is applied to remote control and real-time control communications. Basically, unmanned forklifts are considered first, and a high-precision haptic joystick that can be used in case of emergency is also included in the scope of development. Additionally, technology for allocating optimal tasks and preventing collisions between equipment and facilities will be developed through advanced algorithms. The last of the logistics center automation technologies is one that can monitor the technologies introduced previously. It is possible to observe the status of equipment location information in real time through integrated monitoring. Furthermore, traffic detection technology enables central control and management of any situation in the logistics centers. Finally, I will cover the third research area of the project, which is the development of integrated cargo control technology. The device is first developed for real-time cargo control, and the communication method is configured as a hybrid type that includes LPWA in order to improve battery and communication performance. In addition, cloud technology for real-time information sharing is included in the development, as is smart logistics center technology, so that it enables to grasp the loading location in the logistics center in detail even after the cargo has arrived at its final destination. The integrated control technology provides cloud services to perform cargo transportation through 3PL business support more systematically. Ultimately, devices and individual systems are integrated and interlocked to realize an integrated information platform that encompasses cargo control and 3PL logistics information service. This concludes the explanation regarding the Intelligent Automation Smart Logistics System construction project carried out by BPA. Thank you for your time.